Welcome guys to our new chapter, that is linked list. So in this chapter we'll be covering the following. We'll be looking at the singly linked list overview, looking at the singly linked list implementation, looking at the doubly linked list overview, and then finally its implementation. Thereafter, after everything is done, we then look at some classic interview questions and apply what we've learned. So right now we'll be starting off with a singly linked list. So in the singly linked list, what we'll be looking at is its overview. Thereafter, look at insertion of elements, deletion of elements, sorting of the linked list, and then finally reversing the linked list. So what is a single linked list? This is a collection of nodes that are collectively formed in a linear sequence. Each node stores reference to an object that is an element of the sequence, and also storing a reference to the node of the list. That will be the next node of the list, Then the list instance has a head that identifies the first node of the list. The list also has another instance known as the tail to identify the last node of the list. So right now let's look at an example of a linked list, right? So linked list is basically what we're seeing here. So here on the left, this block will be a node, right? This will be the element or the value. So let's say here the single linked list was a list of numbers. So here we'd say 1, for example. If this was 1, then this 1 will be storing reference to this one, which would be 2. And then this one will be storing reference to what? If there's an element there, then it will be storing reference to another element. But then in this case, it is the last element, so it's storing reference to what? Nothing. So this is an example of how a linked list looks like, right? So now let's look at the insertion methods that we'll be working on today. So we have inserting an element at the head, inserting an element at the tail, inserting an element before another element, inserting another element after another element, inserting an element after another element, So let's start with the first one, inserting an element at the head. So what is happening here is we have one element here, and then the head stores reference to the first node, right, which is this one. So we want to insert an element before this one because we want to insert it here at the head. So then we create a new element, right? And then after creating a new element, we then take the head reference to point to what? The new added element, and then take the next node reference of the new element pointed to the what? To the previous first node. I don't know if that made sense. So for people that also prefer words, so basically the steps is we create a new node. After creating a new node, we set the new node link to refer to the current head, and then we set the list head to point to the new node, right? So now let's try and implement this and then see how this is actually done. Okay, so now let's look at insertion at the head, but then we'd have to first create some view method, that is the display method and the get size method and maybe the search method, and then after we can make our insertion. So we can just say class node. So we'll need our object. So yeah, we then initialize our constructor here within say self. Thereafter, in our self method, we'll need the value. So in our value, we say self.info is equals to the value. So this info is actually the element that we add. If that element is 1, then that info will be having that. And this link is currently none. This link is the one which will be having the reference to the next node. And then thereafter, we then say class. Now our linked list, and then we need our object. Thereafter, we also need our constructor for this. So in here we take no argument, but then we need a self dot root, which is self dot head. That will be what? None currently, right? So that's the head that I'm telling you about, that it holds reference to the what? To the first node. So we then have the display method, so that we can print out, so that we can start our code. So here we take no argument, but then we say if self dot head is equal to none, then we know that it is empty. So we then return the list is empty. So if that's not the case, we then say p is equal to self.head. So by doing that, we want to loop through this entire linked list. We then say while p is not none, we then say print p.info, and then give it that linked list touch, and then we say end is equals to net, and then we say p is equals to p.link, and then thereafter that should do. So just to space out after this, we can just say print. That is done. Now we're done with our display method. Now let's make our count so that we can get size. So to make our life easier, let's have that thing not here, but then let's have it here. So let's say self count is equals to 0, right? So while we're having that equals to 0, what we do is every time we loop through, we'll then say self dot count plus equals to 1, and then that will give us our size. Thereafter, we'll just say define get size, and then we take no argument, and then we say return self dot count. Right, so that is that simple. And then we can have our insertions. So now here we start with insertion. So we want to define insert underscore head, and then what we do is we just give space, and then so what we do is we want to check if no. So because we're inserting near the head, we want to have a temp variable that will be the one that we create. This is the first step. Remember the steps that I told you there, that I wrote 1 to 3. So yeah, we do that. We define temp. This is our new node, and then we need data so that we can pick in the number that we want to input. If we want to input 10, and then this is the data. So after making that temp variable, so it's very vital the way you render your links and everything. So you'll say temp.link should now point to where the head is pointing, right? Self.head, and then we say self.head is equal to what? Temp, right? So this step is very vital. It's very vital. So now this is our insertion and the head. So now let's test it out, and then we look at other insertion methods. So we say link, let's just say link is equals to linked list, and then let's call link dot insert head, and let's insert 5, and then let's just duplicate that 3 times, and then we know we insert 10, then we insert 2, and then we print out our link dot display. That's what we want to print out. And then now let's run this code, and let's see if we're actually getting what we want. And then thereafter we look at insertion at the tail. Okay, let's just print this out. Okay, so linked list object has no attribute head. Okay, so what's happening here? Temp.link. Okay, what's happening here? Linked list has no attribute head. This is initialized. Oh, okay, so init. Okay, let's just clear this out and then rerun. And then there we go. So we're now having a clean linked list. So we first inserted the 5 at the head, and then now we took that head, the previous head 5, and then we put 10 where it is. Hence you see 10 here, and then there's 2 here. Now it's the first element, right? So this is our linked list. And now let's look at insertion at the tail. Okay, so now that we're here, we want to look at insertion at the tail. So now we have 2 nodes here, the first node, the second node, and then if this, because this is the last node, it's pointing reference to what? Nothing. And the head is pointing reference to what? The first node, right? So now how does insertion at the end happen? So we create a new node. So the first step from that other one is still the same as this one. So we create a new node like this. After creating a new node, we then want to make reference from this previous last node. We refer it to the what? To the new node. And then this one new node then refers to what? None, right? Because then this will determine that what? This is the what? The last node. So now finally let's now look at the steps of how we then wanna go about this. So we create a new node, and then we set the link of the old node to point to the new node. So this link of the old node is the what? Is the previous last node, and then we set it to what? The new node. And then thereafter we set the new node to link or to point to none, right? So now let's go back to our text editor and then try implementing these steps. Now let's just close this. So now what's happening here is now we want to have insertion at the end. So say, let me just say insertion head or start. And yeah, we say insertion tail. So we say self dot, not self dot. We say insertion at the tail. We say self. Now we need our data. Alright. So now what's happening is we have some few checks that we need to have. So let's just do that. We need to check if our what's this, man? So we need to check if this list is actually empty, because it could be empty and then we want to insert and then someone uses this insertion at tail. So we say if self.head is equal to none. What we do, we then say self.head is equal to, so we then have to create our temp variable here. We say temp and then pass in that data. So we then say that is equal to the temp. This will only apply if there was nothing in the list, and then we just do it like that. So if there is something in the list, we need to traverse through this list and then until we find the what? The last node. So we then say p is equal to that, and then we say while p dot link is not none, what we do then is we say p is equals to p dot link. P, what if p is not none? We say p is equal to p dot link, and then we traverse through like that, and the moment this thing ends, it is when we add the last element. So we then say that if now we want to swap in this nodes, right? So now we have our new node that was created here. So if then it passed this, and then it will jump here, but then this is still created. So what we do is we want to say p dot link. Remember that link should point to the what? The temp, the new added one, right? And then we say temp now link is pointing to what? None. So this is basically what we do to get our new node at the end. So now let's test this out and see if this is working accordingly. So let's just go down, and then now let's add this one. So we say link dot insert tail, and then we can say 20. Right, so we expect 20, excuse me, so we expect 20 to be at the last added element. So we then do that. So we're getting the fact that none type object has that. So let's see what's happening. Just give me a second. So I say please close out the head. What's happening? I have the link there. And on my head there. This thing is being crazy. I don't know what's happening. So and there we go. So I guess the mistake was here. So what is happening here? So basically, let's say we have 1, 2, then we want to add something here. So if we want to make sure that we're getting the last element, is we need to check if this link is none. So my mistake was not checking if the link is none, because in order for us to know that this is the last element, its link has to point to what? To none. So hence, when we traverse through this entire thing looking for the last element, we have to check if the link is none, because this one is pointing to what? To 2, and this one is pointing to none. And then thereafter, when I want to add my 20, it will come here, because now it has found the p, which is none. So my mistake was there. So now let's move on, and then let's see on how we then insert an element before another element. Okay, so here inserting an element before an element, as we have our 2 nodes as usual, first node, second node, and then this is the last node, and it's also the second node at the end of the day. And then we know that it points to none. This points to the head, points to the first node. So now step is always the same. You create a new node, right? So now let's say that we want to insert an element before the last node, right? So we then create an element here, and after creating this element, we then want to take the previous node of the targeted element. So the targeted element was this one, because we want to insert something before this one. So this is our target. So we want the previous node, the previous link node, that is this one, this is the link, to point to the new node, and then we want this node to point to what? To this one. So let me just go through that again. So this is our target node. We want to insert an element before the target node. So what we do is we want to have access to the previous node of the target node, right? And this is the previous node of the target node. So now we want to take the link of the previous node of the target node, that is this one, and then point it to the what? To the newly added node. And then we now take the what? The newly added link of the node to point to the what? To the target node. And then now we've replaced the ordering of this, and we've inserted this element what? Before this one. And then now let's look at the steps again of how we insert an element before another element. So firstly, you identify or state which element you want to insert before. Remember the target node? That is the one that we're talking about here. And then now you create a new node. And after creating a new node, you then set the link of the node before the marked node to point to the new node. Remember that you have to take the link of the previous node, the previous target node. That is the link before the target node, and then you point it to what? To the link of the, you point it to what? To the new node, I'm sorry. And then you now point the link of the new node to the what? To the target node. So now let's go look at how we implement that, and I hope that will be more clearer when we start coding that up. Okay, so now that we're here in our text editor, now let's look at this insertion before. So we then say find insertion score before, and then we need to take in ourself, and then we need to take in the data, we need to take in the target element that we want to insert before. So this is all that we need. So now there's a few checks that we need. So if self dot head is none, so we know that we cannot insert anything if it is none, because there's nothing that you can insert before. So we just say that, we return that. There's nothing else we can do. Then else, if our if our target is equal to self.head.info, right? That is the first element. It means that we want to insert before that one. So we then say temp is equals to node, then pass in the data. Thereafter we say temp.link is equals to self.head, right? And then we say why is this giving an error? If self.target is equals to that self.head, then we say self.head.link, and then self.head is equal to what? So yeah, we just making our new element, the new node, be the first element. And then else, if that's not the case, we want to traverse through this entire head, not the head, but in the list, so that we can find the target. So we then say while p.link is not none, then what we do is we say if p.link.info is equal to the target, what then do we know that we've reached or we've located the previous node of the target? I don't know if that made sense, and I'll explain that if it didn't make sense. So now we then know that we've reached our point. We then break, and then say p, so that this keeps on going. So now what we want to do is we want to say temp is equals to node, right? And then pass in the data, and then after we say temp.link is equal to p.link, right? We say p.link is equals to the temp. So now let's just test run it, and then I just go through this code, and then we go through insertion after, and then we'll be done with our insertions and done for the tutorial of today. So we then say insertion before. So I want to insert 25 before 10, right? So now let's just test it. Okay, so self.head is none. None is not defined. So self.head, if self.head is none, and then should be proper now. Let's just clear out this output, and then we just run this. No man, let's just run this. Okay, so it's not, yeah, it is doing what we wanted. There's the 25. So we've inserted our element before 10 because we said insert 25 before 10, and then we can just for emphasis, you can say link insertion before. We want to insert 100 before 25, and then there we go. So we have our 100 before 25. So now let's go through this code again so that you understand why we do what we do. So here we know that if there's nothing in our element, there's nothing that we can insert before. Let's take the 0 as nothing, right? Because I don't know how to insert. Let's say 0, this is nothing, and there was literally nothing in the linked list. So what are you going to insert before? Because there's nothing. That's what we're trying to achieve here. And then here is, let's say our target was, okay, so let's say we have a linked list like this: 2, 3, 4. So if we have something like this, and then our target was 2, it means that we want to insert, and we want to insert 100. It means we want to insert 100 where? At the beginning. So that's what we are trying to achieve with that. Now let's even run this. And then our first node here is, let me just open the console so that I can see. Okay, so our first node is 2. So we want to insert an element before 2. So let's insert 1000 before 2 so that it's clear. On the insertion, let's say 1000 before 2. Let's clear this output, and then let's run that. And then there we go. We have our 1000 inserted here, inserted there. So what happened to our 2? Okay, now let's fix that. So that method here is a bit wrong. So this should be like this, I believe. And then that should be proper. Oh my lord. Okay, so let's just try and debug that, and this is forever running. Okay, so why is it going down there to that? Looks like this thing is going control shift yeah, let's just stop this code, and then let me just debug this quick. So we have that if the target is equals to self.head.info, and then temp.link is equals to self.head, and then self.head is equals to temp, right? And then that should be perfect, right? So let's run this and let's see. Okay, so our 2 now, so it's inserting this thing twice. Why is it inserting twice? Because we never break from this, and this what is this? So in this for loop, not this for loop, this while loop is also what being applied. So what I have to do now is I just have to say break, and then that is not giving me access. So if that is the case, okay, so what I have to do is I can just say else, and then I put in this code here. So this is not applied if my other one is being met. So that is what I just have to do, just some simple fixing. So just do that. So don't worry, we'll go over this one more time. So we then have to test run this, and there we go. We have our 1000 added before 2. So what was happening here initially? So initially you saw that it was forever going, right? It was because with that insertion before. Okay, so it was forever going because what I was doing here is I was saying temp.link is equals to self.head, right? And then I said self.head.link, right, is equal to 2, and self.head.link is this one, right? And that time, that's where I missed the entire step. So it should be self.head should be equal to what? Temp. Then the temp link should be equal to what? Self.head, right? And then what we do then now is, why then was it, after fixing that, why then was it printing twice? It was because this if statement was being applied, but then now the code applies everything then after the if statement, because remember that everything was not conditionally blocked. So after the if statement, there was no else statement. So it was jumping through to the what? The rest of the code. Hence, this while loop was rendering everything, right? So now that is insertion before. So now let's look at insertion after. Okay, so now that we have and for insertion after, so now we have our three nodes, yeah, first, second, third, which is also the last and also the first. Yeah, I mentioned that. So now what we do is we now have to create a new node. So if you want to insert after, same applies. You have to have a target of which one do you want to insert after. So let's say we want to insert after this node, right? This is the middle one. So this will be our target element, right? So now, that being our target element, so now we have to take the link of the target element and point it to the what? The new node, and then take the new node, point it to the what? The link of the previous targeted element where it was pointing to this one. So basically, this is the target node. We point its link to this one, and this target node was pointing to this one. So now we take that link of it, we point it to where? This one, but then we use the what? The new node, right? So here are the steps for the insertion of after. What we do is we first identify or state which element we want to insert after. We then create the new node. We set the link of the marked node or stated node to the new node. We then set the link of the new node to the old link of the marked node, right? And that is where the old node was pointing. That's where we want to point with our new node. So now let's go to our text editor. Okay, so now that we are, let's look at that insertion after. So we say insertion after passing self, we need our data, we need our target, right? So what we do is we say p is equals to self.head. So we then say while p is not none, this is what we want to do. We want to say if p.info is equal to the target that, so we know that we've reached our breaking point. So we want to break, and then we just want to keep this thing running if our info is not yet found. So that after, now that we've reached there, we want to say temp is equals to node, and then we get our data. We say temp dot link is equals to p dot link, and then we say p dot link is equal to what? Temp. So this should do. Now let's try and run this and see if we do get what we want. So then say link insertion after. So we want to insert 1000, 100 after 10, right? So now let's test run this and see if we get what we want. And there we get it. We have our 100 after 10. And then we can try and insert 1000 after 100. Insertion after. And then we say 1000 after 100. And there we go. Here's our 1000 after 100. Now let's go through this code and then we understand clearly. So here was what's happening here. Here we have our function, our method, target, and the data. So here we want to use this so that we can traverse through this list. So we use while p is not none, and then if p.info, because we're searching for that target node. So the moment we know that we've reached that target node, we want to break, right? And then this is just helping us traverse through the what? The linked list. So now we then create our new what? Our new node, and then we set the link of the new node to point to the link where the target node um, was pointing, right? And then we then take the link of the target node and then point it to the new node. So this is basically insertion after, and basically this is all the insertion methods that we've covered today for our linked list. And then on the next video, we'll be looking at a deletion of elements, and we'll also add maybe a search method so that we can search through our linked list. So I hope you liked and enjoyed this lesson and learned a lot. Please like, share, and subscribe. Hoping to see you guys in the next tutorial. Goodbye.